Try this right now. Take your own hand and run a finger along the sole of your foot or up under your arm. Go on. Barely anything, right? Maybe a faint sensation, but nothing like real tickling. Now imagine someone else did the exact same thing, same spot, same motion. You'd probably be squirming, maybe even shrieking, unable to hold still. Same touch, same intensity, same location. The only thing that changed is who did it. So why does the exact same touch feel so different depending on whose hand is doing it? This isn't just you being unusually ticklish or not ticklish at all. Try it on basically anyone you know and you'll get the same result. Self-tickling barely registers, no matter how hard you try, no matter where on the body you attempt it. Even people who consider themselves wildly, hopelessly ticklish, the kind who can't survive a light poke to the ribs without collapsing into laughter, still can't get much out of tickling themselves. The sensitivity is still there, it's just aimed at the wrong source. It's one of those strange little facts about being human that almost nobody questions, because it's just always been true. But it turns out this quirk is one of the clearest windows we have into how your brain tells the difference between you and everything that isn't you. Scientists who study tickling actually split it into two categories. The first is gnismesis, that light, feathery, almost itchy feeling you get from something faintly grazing your skin, like a bug crawling on your arm. The second is gargalesis, the much more intense kind that provokes real laughter, usually from firmer, repeated pressure on spots like the ribs, the neck, or the soles of the feet. Charles Darwin wrote about this in the 1870s, noting that laughter-inducing tickling seems to require a playful, familiar relationship between the two people involved. And it's that second category, gargalesis, that is almost impossible to produce on yourself, no matter how hard you press. Here's the almost insultingly simple starting point. Tickling, as a sensation, seems to depend heavily on surprise. A touch that arrives somewhere on your body unpredictably, one you didn't see coming and can't fully anticipate, is far more likely to provoke that helpless, ticklish response. But when you move your own finger toward your own ribs, your brain already knows exactly where that finger is going, how fast it's moving, and precisely when contact will happen. There's no surprise left by the time it lands. It's a bit like trying to surprise yourself with a joke you already know the punchline to. The setup is there, but the payoff has nothing left to deliver. And without surprise, the tickle sensation has almost nothing left to work with. But your brain already knows is doing a lot of work in that sentence, so let's unpack it. Every time you make a voluntary movement, your brain doesn't just send the command out to your muscles and wait to see what happens. It also sends a copy of that exact command, called an efference copy, to a region called the cerebellum. Tucked at the base of your brain, the cerebellum uses that copy to run something like a simulation ahead of time, a forward model predicting exactly what sensation that movement is about to produce before it even happens. When that prediction turns out to be accurate, when the real sensory feedback matches what the cerebellum expected almost perfectly, your brain does something clever. It dampens the resulting sensation. Researchers call this sensory attenuation. It's not that you feel nothing, you still feel the touch. It's that the feeling gets muted, stripped of the intensity and surprise that would normally come with it. Your own touch is about as perfectly predicted as touch can get, so it gets attenuated more than almost anything else you experience. You feel a milder version of this every single time you touch your own arm or scratch an itch without a second thought. Your brain barely flags it as noteworthy because it already knew it was coming. This idea wasn't just theorized, it was tested directly. In 1998, a team at University College London, led by Sarah Jane Blakemore alongside Daniel Woolpert and Chris Frith, built an actual tickling machine. A piece of foam touched a participant's palm in a precisely controlled way, moved either by the participant's own hand through a lever or by the researchers themselves. People consistently rated the researcher-controlled touch as more ticklish and more intense than the identical touch they generated on their own, confirming that self-produced sensations really were being dampened. Then came the twist that really proved the mechanism. The same researchers added a short delay or a small change in direction between the movement of the participant's hand and when the foam actually touched their palm. Suddenly, self-tickling started working better. Even a delay of a fraction of a second was enough to throw off the cerebellum's prediction. Once the timing or the location no longer quite matched what the brain had forecast, the attenuation broke down and more of the ticklish sensation came through. Brain imaging backed this up too. When people were touched by someone else, areas of the brain involved in processing touch, including the somatosensory cortex, showed a stronger response than when the exact same touch was self-generated. Your brain isn't just deciding after the fact to shrug off your own touch. It's genuinely processing it less, at the level of raw sensory signal, before it ever reaches conscious awareness. This also explains a detail you may have noticed if you've ever tried to cheat the system. Holding a feather in your own hand and dragging it across your own skin doesn't work any better than using your bare finger. It's not about direct skin contact. It's about whether your brain is the one commanding the movement. As long as you are the one initiating and controlling the motion, the forward model kicks in and predicts the outcome, tool or no tool. Even a mechanical device you're actively steering with your own hand runs into the same wall because control, not contact, is what matters. There's also a deeply social layer to all of this. Tickling appears to be an ancient behavior, not just a human quirk. Great apes, including chimpanzees, bonobos, gorillas, and orangutans, produce laughter-like vocalizations when researchers tickle them during social play, and studies comparing these calls to human baby laughter suggest the behavior shares a common root, going back at least 10 to 16 million years. Some researchers argue that tickle-induced laughter evolved partly as a social bonding signal, reinforcing trust between the tickler and the one being tickled. That social context may be part of why self-tickling falls so flat. There's no other participant, no relationship, no element of playful vulnerability to draw on. Here's where it gets genuinely strange. Researchers have found that some people with schizophrenia, particularly those experiencing what are called passivity symptoms, the unsettling sense that your own actions or thoughts are being controlled by an outside force, show much weaker sensory attenuation than most people. In some studies, these individuals could partially tickle themselves, something that almost never happens in people without those symptoms. Their brain's forward model, the very system that predicts and cancels out self-generated sensation, appears to be working differently. So why would the brain bother building this elaborate cancellation system in the first place? The leading idea is about attention. Touches, sounds, and sights that you cause yourself are the least likely to signal anything you urgently need to react to. An unexpected touch you didn't predict or initiate, on the other hand, might be an insect on your arm, another person, or something in your environment worth noticing right away. By muting the predictable, self-caused stuff, your brain keeps its attention free for whatever is genuinely new. In a strange way, then, not being able to tickle yourself isn't a limitation. It's evidence of a system working exactly as designed. A running, moment-to-moment simulation your brain builds of your own body and its actions, quietly drawing the boundary between what you did and what simply happened to you. So the next time someone sneaks up and gets you right in the ribs and you can't stop laughing no matter how hard you try, remember what's actually happening. It's not a weakness or some strange oversensitivity. It's your brain correctly recognizing that this particular sensation was not one it predicted and reacting accordingly. You may never be able to tickle yourself, but now you know it's proof that your brain is doing exactly what it's built to do. And maybe that's the real punchline. The one part of your body you can never truly surprise is the part that is most thoroughly, reliably yours.